Whoops. There we go. All right. So Derek Walczak coming to you live from Consensus 2018 in New York. I'm excited this morning because we're going to be interviewing fetch.ai, which is a completely a very interesting and large project. It's very different than anything that I've seen that's being pitched around up here. So this morning we have Toby Simpson. Toby, will you introduce yourself?
Yep. Hi, I'm Toby Simpson. I'm the CTO and co-founder of fetch.ai.
All right. So Toby, we were talking a little bit earlier. You were involved in some video games in the 90s that had some popularity.
Yeah, absolutely. I was doing computer games throughout the 90s, but I had the privilege of being involved in a product called Creatures in the mid to late 90s. Creatures was an example of artificial life. And what I really liked about it, other than the fact that it showed me that nature has a lot to offer when it comes to showing how you can solve the problems of artificial intelligence, is that it used a large population of simple things that work together and solve big complicated problems without me actually having to know quite how those problems were solved. And I was kind of curious at the time as to whether or not that bottom-up philosophy of building these large populations of simple things could be used to solve bigger problems, such as creating huge virtual worlds and filling them with different things. I did that for a while in the early 2000s and spent a little while at DeepMind looking at how nature can contribute towards artificial general intelligence. And then got involved in doing Fetch because myself and the other two co-founders of Fetch, one way or the other, have been talking for the last 10 to 15 years about how we could construct a world of such magnitude that we could do really interesting economic work inside it. And then, of course, along comes decentralized ledger technologies, and we suddenly realized, well, hey, now we can actually create something of the scale that we need in order to be able to do the kind of things that we want to do.
So, you mentioned there's two other partners, two co-founders, I assume. Tell me about them, who they are, and kind of their backgrounds.
Yep. Well, there's Humayun Sheikh, who's the CEO, and he also has a background in some areas of computer games and a lot of AI, and also commodities trading and supply chains. And there's Professor Thomas Hayne, who's Professor of Machine Learning at the University of Sheffield in the UK.
Okay. So getting into Fetch, so we were discussing off camera, and you were helping me to break it down into some base parts. Give me the high-level explanation of what the problem you're trying to solve and how you're going about that.
We live in an increasingly complicated and very, very busy world that has more and more moving parts. And one of the problems with looking after so many moving parts in such a complex environment is it gets very, very hard to do that from the top down. And we wanted to create a scenario where if you could give all those individual moving parts their own autonomy, their own lives, their own ability to control their destinies and exchange value, that you could solve these complex problems that we're presented with from the bottom up. So without you having to go out looking for solutions, the solutions could find themselves and present themselves to you.
So, okay, so you have these, what did you call them, agents?
Yes.
So these agents would be the very base level of an autonomous thing that would live on phones, sensors, cars, basically grabbing data and then figuring out how or serving up opportunities for you to commoditize that data and selling. Is that how it works?
Yes, you can look at it as digital representatives. Pretty much any device, any piece of information, services, people, hardware could be represented by a digital entity that's able to go out and do things on its own behalf. So what we've actually created and what Fetch is a decentralized digital world in which useful economic activity can take place. That economic activity is done by these agents. We call them autonomous economic agents. And they can work on your behalf, on their own behalf, and they can work together as groups or indeed individually. And they live in a world which is structured and adjusted in real time just for them. And that's one of the things that's really exciting about it, that they go into a digital world, and I refer to it as the ultimate dating agency for value providers, that actually restructures itself in real time to present in front of you all the things that are most relevant to what it is that you want to do. And that, we call that the open economic framework. It's the digital world itself. It's effectively the eyes, ears, senses. It gives you an ability as a digital entity to walk around and explore this amazing space, delivering value and finding the things that you want to find. But all this has to be underpinned by something, and that's underpinned by our smart ledger. And we had to do a great number of things with that in order to make it work. And due to the huge scale of the kind of things that we're trying to do with Fetch, where potentially tens, hundreds of millions, or even billions of digital entities might be transacting and exchanging value on a network, and that required some interesting new innovations to make something like that scale and work.
So, without getting into your patented stuff, or however, without getting into the secrets, can you illustrate a little bit more, like how you overcame some of those problems?
Yeah, absolutely. One of them is creating a ledger that really scales. When you're looking at the kind of transaction counts that we're talking about, you need something that will just continue to scale, so that if huge numbers of agents are doing things, then you have the ability to push those transactions through. And to do that, we've came up with a whole new approach to creating a ledger. It's a combination of a variety of things, but one of the things that we worked out was how to parallelize transactions that don't affect each other. But then what was really interesting about it is the job of organizing those transactions effectively in order to parallelize them to the maximum level that you can is actually done by the users of the network as part of the proof of work, as forming consensus. And we call that useful proof of work, because the actual nodes on the network, as part of building and optimizing the blocks, are actually increasing the throughput and the performance of the network. And we've had to add, for example, to that a side DAG, I guess I would call it, a directed acyclic graph that stores the results of that useful proof of work, provides an election mechanism in order to ensure that there is a selection process for choosing the best block in order to go onto the network. And using this, we've been able to achieve a huge number of transactions. But what we really realized with useful proof of work is we didn't have to stop with block optimization. We could actually use that to solve other machine learning and AI problems, and we can use that to build a prediction model so that we could deliver predictions to the users of the network, but also trust information. And trust information is really interesting, because if you had to wait for a given transaction to go to the global state before you were able to continue, that may only be half a second or a second, but if there's 100 transactions involved, that potentially all adds up. That's a long time. And the trust mechanism that we've got, which as the transactions go onto the network and move around, they get signed, it gets put through a Bayesian network and delivers this real-time trust information, means you can look at any given transaction and go, oh, right, yeah, that one's got a 97% chance of making it to the global state. I'll go with it. And that means you can make those decisions very, very quickly. And that also dramatically improves the throughput of a network like that.
So the base layer, the network, did you fork that from Ethereum, or did you come up with your own basic?
Yeah, we had to come up with our own in order to make that work. The problems that we were dealing with were very, very different. The scalability that we needed to achieve, that was something that we couldn't do, but also we couldn't afford for information, key information about the value exchanges that take place to be lost. As part of a settlement process or anything like that. The machine learning algorithms and as part of the useful proof of work mechanism needs access to that information as it goes by. So that did require a very different structure. But also we're doing something very differently. This isn't just a case of allowing large numbers of transactions to go through. This is a decentralized digital world. So we're trying to add geography to this network. This is Web 3.0 as a place that you go. We want it to be possible for agents to be able to say, I want to know what's going on in that direction, or over there, or behind me, or within a range. Because a number of the big problems that get solved, things like transportation issues and other complex solutions for users, involve things that are geographically based as a method of sorting. And that digital world, in a multi-dimensional way, also required a whole bunch of different structures at the raw network level.
So tell me about the different verticals. Tell me about maybe 2 or 3 verticals, and then go deep into one and explain how Fetch will solve problems.
Well, as we touched on before we started recording this, right. We were talking off camera, you said that one of the problems with a thing like Fetch, where you could potentially have a digital representative for almost everything. And when you think about the amount of data that we use right now, what's more interesting is actually the amount of data that we simply don't use, either because we don't know it's there or because the cost to extract it and deliver it exceeds its value. Of course, when you can attach a digital representative to everything, then that cost plummets. You can bring all this stuff into play, which is really interesting, but when you're sitting in a world where you could do anything and everything, how on earth do you know where to start? So that's one of the things that was very important with Fetch. We had to look at all this and think, okay, well, we do need to focus this in some of the areas where we know that this technology can make a great deal of difference. Areas where there are a great number of moving parts that could genuinely be improved, the experience for everybody. Utilization values could go up, it's a better experience for users. And of course, transport is exactly one of those things where if you put represented on pretty much everything that surrounds you, you can buy from those in front and you can sell to those behind you. You've got this shifting wave of useful information that can improve the experience for all, but it can be delivered to you rather than you having to go out and find it. And ultimately, as the world changes and you can automate individual segments of roads and other bits and pieces, then there's more control afforded to this complex system. You can poke it in different ways, you can manage it in different ways, you can deal with the peaks and the troughs, you can flatten the demand and make the whole experience better for everybody. So transport was definitely one of those areas where we realized that Fetch could make a great deal of difference, and it's certainly one of the areas that we're concentrating on. But also supply chain management. There's a lot of areas there when you look at certain parts of supply chain management, and it really does look like a journey into the past, where utilization is not nearly as good as it could be, but it's because it's a lot of moving parts, and one top-down entity finds it very hard to hold the entire problem in their mind.
Right.
But if you can put that out into the individuals to solve by themselves, the digital ones, without you having to worry about it, you get a better flow, but more adaptive and dynamic flow.
So I understand. So how do the individual sensors or the individual agents have a concept of the problem that they're trying to solve?
They have a concept of what it is that they have. It's the network that builds the solutions to the problems by connecting people who want that information or who might want it.
Okay.
So an individual agent representing whether or not a windscreen wiper is functioning in a car or a vehicle at any given moment doesn't know where it's going to be able to deliver that value or how it's going to be able to deliver that value. The network, when it goes into the network will position it, again, this is the dating agency for value providers, it will put it in a world tailored and adapted just for it, where everything it sees are things that are most likely to want that information. And we use a number of machine learning techniques, including a really neat reinforcement learning system, because of course we know whether any given prediction or correlation that we deliver, we know whether it works, because we can see whether any value was exchanged as a result of it. So the ones that aren't working, well, we can degrade those out of the system, and the ones that are, we can reinforce them and give them strength. And that allows the network to adapt very, very quickly, but also to explore new interactions between things that are non-obvious. Yes. And that's what's really interesting, the idea that non-obvious correlations will be drawn by the network just because it watches what's going on, which introduces more opportunities to use this value, and for that just to be handled as a fact that you're in Fetch as opposed to anything else. So no, you don't need to know, these entities don't need to know where they're going to deliver it. The network will ensure that people that can use it are right there.
Okay, so how does Fetch make money? I mean, I could imagine some different business plans, but help me understand how the network will make money.
Fetch is an example of a tokenized thing. It's a non-permission public network, so anybody and everybody is able to set up nodes, but also to set up and build their own autonomous economic agents. It's one of those things that is open to all. So as people proceed to work with the network and they do things with the network, then the values of the predictions and the correlations that are delivered, that gains in value. So all users and stakeholders in the network gain value as the network grows and is used by more people.
Okay. All right. So what is the roadmap ahead for Fetch? What does the next couple of years look like?
very busy. Very busy. But what we do have right now is internally we have a private a test network that's actually up and running. So our key innovations, particularly relating to the ledger and the machine learning side, the useful proof of work and the virtual machine that drives that, we actually have all those things up and running. And the initial digital world, we have that working too. So you can actually build agents, and we have done, and you can put them in this world. They can find each other and they can exchange value. And all of that happens on the Fetch network. Over the summer, we're looking at a public testnet release. That's really exciting because that means that anybody and everybody will be able to try things, to see what they can build. They can attach digital representatives to all sorts of things and just see what happens in this network. And that's super exciting. I can't wait to see what people will build with that. And towards the back end of the year, as we add more of the machine learning and the artificial intelligence to the system, that network will slowly fill out with all the functionality that we're talking about. And we're looking at a main network release towards the back end of the first half of next year.
Mm-hmm. Okay, and then you mentioned that you'll have tokens. With the sale of tokens, or I know you didn't want to get into the details, and you don't have to, but is that probably a 2019 deal?
We haven't made any announcements about that yet, but this is a tokenized business, and actually that's very, very important because you want it to be able to you want people, no matter where they are. This is an inclusive network to be able to perform these things, and you need some common method of being able to do that over the network. So we've had to come up with a method of doing that, and a tokenized business is by far the best way of achieving that, particularly given the underlying decentralized ledger technologies.
Okay, that makes sense. So, all right, so before we talk about how listeners can participate and interact, is there anything else you wanted to explain or a question that I didn't ask that I should have relative to your project?
No, I think we did pretty good. For me, the idea when we're sitting here in the real world, the two of us in this room, we have to see the same world. We're, albeit from a slightly different perspective. With the digital world, there is no such restriction. And that, to me, is really exciting because something can be close to you, even if it's not physically close to you, just because it's important to you. And having the Fetch digital world restructure that for every individual so that it is perfect for value exchange, that's one of the things that excites me most. And being able to build a virtual world of this magnitude that could keep getting bigger with a population of this size in it, well, the kind of things that billions of autonomous economic agents might be able to achieve if they work together, well, who knows where that might go. And that's a dream come true for me, given all the work I've done with virtual worlds and digital worlds to allow so much useful work to be able to take place in something of this size.
It reminds me of a quote, and I can't remember who said it, but it may have been Jack Dorsey. I can't remember who it was, but he basically said that the closest thing to digital life that he's ever seen is the blockchain. And so this certainly goes to reinforce the idea of that, because you're creating these autonomous agents that can do things, and then they interact with the ledger, who then can take the information they've given and create relationships and opportunities to commoditize it, and find relationships that humans probably couldn't even have concept of, which is completely fascinating. So for listeners, how can they interact with Fetch? What would you like for them to do?
Come and join us on Telegram. Come and ask us questions and try and imagine amazing things that you could do with this, because what we've managed to come up with is merely the tip of the iceberg. I think your quote there was really interesting. When you get all these little things working together, who knows what might emerge. I mean, it is a great example of a life form, a new form of economic life in the case of Fetch.
Yeah. Very good. Toby, I'll tell you, Toby Simpson, and probably he will have the absolute best accent of anyone that I will interview here at Consensus, without a doubt. It's fantastic. Where specifically, where did your accent come from?
That's an interesting, tough one, because it came from my mother more than anything else. But a combination of different places in the UK, the south of England, the east of England, and now in Cambridge. Okay. So it's sort of a mixture of all of those joined together.
It's very good. It's different than my Southern drawl. Very good. Okay, so we'll have in the show notes, we'll have information on how you can get in touch with Fetch. But for Telegram, it's fetch_AI. Toby, thank you so much. I think this has been great. Very good.
Thank you very much.
Okay.
Monuments crumble in the blink of an eye.